Okay, what you're about to see is, well, actually, hold on. All right, now I've got it ready. This is a real-time simulation of world events in the atmosphere put together, I don't know by whom, but a student of mine actually brought this to our attention in the Department of Physical Sciences at the College of Southern Nevada. And so I've been using this, so I'm sort of playing around with it in order to see a little bit more about what's going on. It's taught me a few things. It's been useful to illustrate the importance of scale and reading scales, because some of the information you're going to see in this video is a little misleading. And then to give you an idea of things that are changing and things that I didn't expect, because some of the things you've been told are not necessarily the case, and some of the information you're going to see here does not corroborate the conclusions that you hear in the media or from scientists elsewhere. And so we're presenting this as real-time scientific data gathering and commentary, running commentary as I watch this. It is currently 9:37 p.m. on Monday, March 13th, 2017, and the Earth is centered here. What we're seeing first off is this is surface winds, and so you can see there's not a lot of wind. Oops, not sure why that happened. My computer is slower here than at work, so it's got to equilibrate. So there's some storms down here in the way south Pacific. But we're not really interested in the wind. What I'm really interested in is chemicals, because you've heard about chemicals and you've heard about, how bad it is. So once this downloads the information, what we're going to start off first looking at is carbon monoxide. And this is where I want to draw your attention to the scale. If you look at the scale, this goes from 66 parts per billion up to a maximum of 2456 parts per billion. So we're going to go back and look at North America first, because everybody thinks that North America is a big producer of carbon monoxide. So if we look here in the Los Angeles area, what we see is 1148 parts per billion, which is fairly significant. And then up here, this is in the New York metropolitan area. That's that particular region shows 686. So if I can find anything higher, I guess it's night there and middle of the night, so I wouldn't expect there to be as much carbon monoxide. It's interesting sometimes as you look around the globe, and we're going to look just briefly, you see there's some hot spots even in South America that are above zero, and then we'll go over here to Europe, where this is an interesting part of Africa we'll come back to later, right here in equatorial Africa. But you look up here in Europe, and this, it looks like Russia. Russia has almost as much as Los Angeles. It's 956 parts per billion. Here's a place in the Netherlands with 360. Looks like Ukraine, 350. So it would seem to corroborate that the U.S. is a major carbon monoxide emitter. This is the Indian subcontinent, 580, 547. And then we go to China. Keep in mind that it's about noon in China, so their industrial output is ramped up. We have northern China, that's 497, 901, 1197. So you can see that carbon monoxide that China is producing, I mean, look at this region here, where there's clouds all over the place, where it corroborates the news that you've heard that China has a pollution problem, and shows that China, compared to the United States, at least at night, and I'll do another one of these at a different time of day to show you that China is polluting at least as much as we are. Okay, now we'll switch over to carbon dioxide. And here's another one where the scale, I mean, look at the vast difference in these colors. And you see down here in the rainforest of Brazil, it's very dark. This is misleading. The very dark is 361 parts per million, and the very light is 468. So it's actually only a difference of 100 parts per million, or 0.1 milliliters. if we're looking at a volumetric scale when we look between the two. So here's the rainforest down here. That says 401 parts per million, and then we look up here in that same part of California, and it's 417. So even though the color looks very drastic, the difference is actually minor. There's the most CO2 actually here in the Midwest, but it's still only 425, 424, 420. It's not as high as you would think. So let's go back over here to China, because I'm finding the greatest comparisons with value to be with China. And you'll see, this is taking longer to load on my computer than at work. Here's 433, 437, 432. There's a rainforest area here, 393. So CO2's difference is very, very minute, even in places that are currently at high manufacturing levels. So despite what you may have heard, this is sort of a misleading scale, and we're talking about a 33% difference from this rainforested area, and not even that much, 396, to this heavy concentration of 437. So that's only a 10% increase in base level CO2 levels in the atmosphere. 10% difference of something that is less than 1% of our total atmospheric gas? Really? All right. So let's go back to the United States for the last one to give you an idea of what we're looking at here. And as a baseline, because again, I want to compare us to others. We're often vilified, and this is sulfur dioxide. Sulfur dioxide is typically associated with coal burning. It is currently still winter in much of the United States, and there's a big storm going into the eastern United States, so that accounts, I think, mostly for this concentration that you will see. Again, let's look at the scale. It ranges from 0 micrograms per square meter to 698 micrograms per square meter. So this one actually does go down to 0, so I like it, because that means if you find something like Greenland, it's 0. And you would expect that because there's no coal being burnt there. So let's go back to this section of Los Angeles we looked at before. 0.22, they don't have a lot of coal there. And where I'm at in Vegas, 0.15, oh, we have even less, which is sort of ironic. Then let's go to the Great Lakes here. 28. So remember, 28, the max scale here, 819. There's 100. Look, that's in Canada. 130. All those dastardly Canadians. Okay, so it looks like maybe the United States isn't the big culprit after all. And then for grins and giggles, I like to go this way around the globe when looking at it to show you. Look at all of this coal. This is Saudi Arabia, 45. Russia, 767. Okay? I don't care what they say about us and our coal. That is way higher than, and it's at night, and they're burning it for heat in the United States. Okay? And maybe they don't need as much light. Here's Holland, 32. Some other places in Russia, 181. I don't know what's going on in any of these places. And some of these places down in Africa sort of make me wonder, what are they doing down there? And then we come over here to what most people think of as Asia. And we have the Indian subcontinent, 75, 51, 86. And then we go to China. And that was not a good spot. 27, 35, 143. 49. So even China doesn't seem to be burning as much coal as Russia. But you can see if you compare the cloud here over China to the cloud over India to the cloud over Europe, the border here. Let's see, this would be Poland right here. This is Germany. This is Russia. I mean, look at Turkey. 54. Look at all the sulfur dioxide they're putting into the atmosphere. And you compare that to the United States. Okay. And yeah, there's a fair amount of concentration in this region, 17, 10 micrograms, 37. But again, remember these Canadians up here, 76 and 134. Okay, it's nowhere near the maximum. The maximum is now 644 because that's the maximum recorded on the Earth at this current time. But basically, one of the things this shows is that pollution and its effect on global conditions is not as straightforward as we think, nor is it constrained to to industrialized Western nations like the United States, nor are we the biggest contributors. I've never heard anyone bastardize the Russians or the Canadians, and as we see here from our SO2 levels, there's this place just on the Canadian side of the Great Lakes that's putting out any, I'll try, but I really don't think any of these come anywhere close. And again, you see 4.5, and it looks like it's in this really concentrated region. And then up here, there's none. That's just probably because nobody lives there. And let's not forget all the people along the Andes Mountains here. But even then, see 1, 2, 4, and they look dark. So sometimes the data is very misleading. It's one of the big problems I have in scientific data reporting is with the scale, as I mentioned before, and then this sort of misleading colorization scheme that makes it look like some of the places are much bigger of a deal than they actually are. This seems like a sliding scale, 0, then, come on, you're not going to show me, 0.01. I mean, look how far we've gone up the scale to get to 0.01. So it's heavily weighted at the bottom, and then it scrunches together. This is a poorly weighted scale and a very poor way to report data. Again, this is you can find this for yourself at earth.nullschool.net. I'll put the web address in the comments section below, or in the information section below, and you can feel free to play with this for yourself. I'll also make more of these on other days so we can talk about the differences between time of day, days of the week maybe, and then other conditions, because of course you'll see different things. And they don't save any of this data. This is all projected in real time. I don't know a lot about it, but it has shown me that things are not as they seem, and that it's obviously not as simple or as widespread as they like to claim, at least not in the United States, and our contribution to it as a world power. So I wanted to show you this tool, show you what it's taught me, and let you play with it so that maybe you can learn a little bit more about the world and take the things that scientists tell you with a grain of salt. Always look at the data. Always do your own homework. Do not rely on other people to interpret it for you. Otherwise, it's fake news, pseudoscience, and either not useful or not trustworthy. And everything I would do differently in my life is because the information was either incomplete or inaccurate. I leave that with you tonight to ponder on, and good luck in your science.